Welcome to the lecture number 5 of the course Quantum Mechanics and Molecular Spectroscopy. In the previous lecture, we were looking at the time dependent perturbation theory of two states. If we had the time independent Hamiltonian H naught and had two solutions, E22 such that 1 and 2 form a complete set, and so it also means form a orthonormal complete set. That means integral 1 overlap integral of 1 over 2 will be equal to 0 and overlap integral 1 over 1 equals to 2 over 2 equals to 1. Okay. Now, in the last class we had ended up with this equation I h bar A1 dot t e to the power of minus I E1 t by h bar 1 plus A2 dot t e to the power of minus I E2 t by h bar 2 equals to h prime of t e to the power of minus I E1 t by h bar A1 A1 of t 1 plus h prime of t e to the power of minus I E2 t by h bar A2 of t 2. So, this is where we stopped in the last lecture, okay, and this we came from LHS and this came from the RHS. Now, we have to equate this and try to get going to what happens. Now, I am going to do one simple trick, that is I am going to multiply with psi 1 star on left and integrate. So, which simply means that I will carry out the operation 1. So, when I look at the LHS, then it will become I h bar, okay, 1 A1 dot t e to the power of minus I E1 t by h bar 1 plus 1 A2 dot t e to the power of minus I E2 t by h bar 2. That will be your left hand side, and the right hand side will be 1 h prime of t e to the power of minus I E1 t by h bar A1 of t 1 plus 1 h prime of t e to the power of minus I E2 t by h bar A2 of t 2. So, these are the 4 terms that we have. Now, if you look at the left hand side, then what we have is I h bar, okay, 1 A1 dot t e to the power of minus I E1 t by h bar 1. Okay, I will come to second term little bit. First let us just look at this term. What is A1 dot t? A1 dot t is nothing but d by dt of A1 of t. What is A1 of t? It is a time dependent. Okay, A1 of t is okay, nonetheless even if it is time dependent, it is a constant, it is going to change but it is still a constant. Okay. But this wave function 1 is a solution of the time independent Schrodinger equation. So, what was 1? 1 is nothing but h naught 1 is equal to E1 1. So, the operator in here is time dependent and the wave function is time independent. Therefore, one can write, you can bring the operator outside because it is not going to affect the wave function. So, what we will have, left hand side will have IH bar A1 dot t e to the power of minus I E1 t by h bar 1 1. And the second term which I have not written here, but by analogy one can write it as A2 dot t e to the power of minus I E2 t by h bar 1 2. So, that will be your left hand side. Now, let us look at the right hand side. So, LHS is equal to, I will separate them and then equate it later. So, RHS is equal to, what you had in the RHS? RHS you had H prime 1 H prime of t e to the power of minus I E1 t by h bar A1 of t 1. So, that is what you had, one of the terms. Okay. Now you can see that e to the power of minus I e to the power of minus I E1 t h bar and A1 of t, these are just time dependent phase factor and a coefficient which you can bring it out. But I cannot bring out h prime of t because it is a time dependent perturbation. A perturbation always moves the states. So, it will affect your wave functions. A perturbation really affects a wave function, and if you have time dependent perturbation, its effect will be different in different times. Therefore, one can write this, the other term we had was 1 h prime of t e to the power of minus I E2 t by h bar A2 of t 2. Okay. So, that was your RHS. Okay. Now, this I can slightly rewrite because of the arguments that I use, will be equal to A1 of t e to the power of minus I E1 t by h bar 1 h prime of t 1 plus A2 of t e to the power of minus I E2 t by h bar 1 h prime of t 2. So, that is your RHS. Okay. Now, let us equate RHS and LHSC and what we get. So, IH bar into A1 dot t e to the power of minus I E1 t by h bar 1 1 plus A2 dot t e to the power of minus I e2 t by h bar 1 2 should be equal to a1 of t e to the power of minus I e1 t by h bar 1 h prime t 2 plus a2 t e to the power of minus I e2 t by h bar 1 h prime t 2. Okay, that is what you will get. Now let us look at this. Now we know the equations or the wave, sorry, now we know the wave functions 1 and 2 are orthonormal, which means 1 integral overlap integral will go to 1 and 1 2 overlap integral will go to 0. That means on the left hand side only one term will survive. So what you get is I h bar a1 dot t e to the power of minus I e1 t by h bar, that 1 is just 1, should be equal to a1 of t e to the power of minus I e1 t by h bar 1 h prime t 1 plus a2 of t e to the power of minus I e2 t by h bar 1 h prime t 2. Okay. Now we will have, now let us suppose you have two solutions. This is your 1 with E1 as the energy and this is 2 with E2 as energy. Now I apply, so let us suppose there is a molecule which is sitting here. Okay. I apply the perturbation and what happens is that the molecule after I apply perturbation still is in 1. Okay. So let us say after perturbation I will get another molecule which is this, but it still is in the E1 state. That means whether you apply perturbation or not apply perturbation, okay, you will not be able to differentiate. So if I start with state 1 and end up in state 1, you do not even know whether you have started and ended or not. Therefore, any perturbation which leads on to the same wave function can be neglected. Okay. It is like transition to the same state. You start from ground state and you go back to the ground state. So you do not even know whether the transition has taken place or not taken place. Therefore, one can equate this term to be 0 because the perturbation here acts on state 1 and overlaps with the state 1. That means you have started with state 1 and ended with state 1, you do not even know whether the perturbation has taken place or not. Okay. So effectively the first term will go to 0. Okay. So this is nothing but transitions or perturbations to the same state do not count. Okay. Now in such scenario then your first term is gone. So what you get is I h bar a1 dot t e to the power of minus I E1 t by h bar equals to A2 of t e to the power of minus I E2 t by h bar 1 h prime t 2. Okay. So that is one equation that we will get. Okay. Now let us do this. Let us go back to the first equation that I wrote in the beginning of the lecture, that is nothing but I h bar A1 dot t e to the power of minus I E1 t by h bar 1 plus A2 dot t e to the power of minus I e2 t by h bar 2 should be equal to A1 t h prime of t e to the power of minus E1 t by h bar 1 plus A2 t h prime of t e to the power of minus E2 t by h bar 2. So, that was the equation that we started with. Multiply with psi 2 star and integrate. Okay, this is equivalent of 2. Okay. Now remember, last time we multiplied with psi 1 star and integrated. Now we are multiplying with psi 2 star and integrated. So quickly I will write, skip couple of steps because you already know how we did it with the psi 1 star. So what we get is this I h bar A1 dot t e to the power of minus I E1 t by h bar 2 1 plus A2 dot t e to the power of minus I E2 t by h bar 2 to overlap integral should be equal to A1 of t e to the power of minus I E1 t by h bar 2 h prime of t 1 plus A2 dot A2 not A2 dot t A2 t e to the power of minus I E2 t by h bar 2 h prime t 2. Okay. Now we use the same analogy as last time. So 2 1 overlap integral will go to 0, 2 2 will be 1. So this integral we do not know, we have to evaluate, but once again transitions from 2 to 2 will be equal to 0. So this will go to 0. Okay. So after this we can rewrite this equation as I h bar A2 dot t e to the power of minus I E2 t by h bar should be equal to A1 t e to the power of minus I E1 t by h bar 2 h prime of t 1. Okay. This is the second equation. Okay. Now what I will do is I will correct both the equations together. So first equation was I h bar A1 dot t e to the power of minus I E1 t by h bar should be equal to E2 of t e to the power of minus I E2 t by h bar 1 h prime of t 2 and I h bar A2 dot t e to the power of minus I E2 t by h bar, this is equal to A1 of t e to the power of minus I E1 t by h bar 2 h prime t 1. Okay. Now there is something else that I can do is I will take the I h bar, slightly rearrange these two equations. Okay. So A1 dot t equals to the I h bar I can take on the other side. So I becomes 1 over I h bar, okay, e to the power of E1 t I E1 t h bar by h bar I will take the other side. So that will become e to the power of minus I E2 minus E1 t by h bar 1 H prime of T 2, and the other equation will become A2 dot T is equal to 1 over I H bar e to the power of, okay. Now this is E2 minus, so that will become I E2 minus E1 into T by H bar 2 H prime T 1. Now let us say E2 minus E1 is equal to delta E, this is equal to H bar omega 21. Okay, omega 21 will be the angular frequency, thus corresponds to the energy difference between the E2 and E1 states. So therefore, now you can see when I replace E2 minus E1 as H bar omega 21, this H bar in the numerator and this H bar in the denominator will get cancelled. So what you finally end up with the following equations. A1 dot T equals to 1 over I H bar A2 T e to the power of minus I omega 21 T 1 H prime of T 2, and A2 dot T is equal to 1 over I H bar A1 of T e to the power of I omega 21 T 2 H prime of T 1. Okay. So these are, so which means the time dependence of A1 will depend on A2 and time dependence of A2 will depend on A1. That means these two equations are coupled differential equations. Okay. Now more importantly, one thing that you can look at is the following: A1 changes, okay, with respect to A2 and A2 changes with respect to A1. Okay. Now there is one thing that is very interesting is this here. This is e to the power of minus I omega t and this is e to the power of plus I omega t. So which means these two are phased out. What it means? It means when A1 goes up, A2 comes down, and A2 goes up, A1 comes down. So these are phased out or out of phase with respect to each other. So coefficients A1t and A2t are out of phase with respect to each other. Okay. So what is A1 and T? Psi of x comma t is equal to A1 of t e to the power of minus I E1 t by h bar 1 plus A2 of t e to the power of minus I E2 t by h bar 2. So this was our total wave function, okay, and this is are the coefficients, time dependent coefficients of the A1 and A2, and we know the square of the coefficients gives you the probability. Therefore, okay, so when you see that A1 and A2 are out of phase with respect to each other, that means the probability of finding A1 state, if it goes up, the probability of finding A2 state will go down. Similarly, if the probability of A2 state will go up, then the probability of A1 state will go down. So they are going to be with respect to each other phased out or out of phase. We will stop here and continue in the next lecture. Thank you.